Hello and welcome to the first lesson of Unit 5, Solving Quadratic Equations in our Grade 10 Academic Math class. So this unit it's a relatively short unit compared to what we just went through with quadratic relations. In order to understand what it is that we're after, your notes include this like Unit 5 kind of like summary of what we're going to be doing. And it starts with a comparison of what a quadratic relation is versus a quadratic equation. So a quadratic relation, I'm going to zoom in on that. Quadratic relation is basically what we just spent a whole unit 4 working through. We have quadratic relations. As you can see here, one of the standard form that we have here, y equals ax squared plus bx plus c. What I want to point out about that specifically is what you'll notice is we have two variables happening here. We have our x's, which I guess is really just one type of variable, x, and we have y's. So we have input variables and we have output variables, and that's what our little summary says here. Quadratic relations have two variables and will produce an infinite number of points. So basically, we keep putting in x's, it keeps spitting out y's, and it will always sort of have this true left side equals right side thing going on. However, a quadratic equation, which is over here, what you'll notice is that there is only one output value, and the output value that we're looking for in this case is 0. So again, it's the same, it's set up in a similar way where you've got a form of a quadratic here, ax squared plus bx plus c, that's standard form, but instead of its output value being y, what we're curious about is what values for x will necessarily spit out an output of 0. So we're not concerned with like a variety of outputs, we only want to know what x values will drive this quadratic equation to be equal to 0. So as you can imagine, with only one variable, we're trying to solve now. We're trying to figure out what will make the left side equal to the right side, and our possible answers range from 0, 1, or 2 different values that will make the left side equal to the right side. Now just to tie this back to what we've been doing, I do want to just draw a quick couple sketches up here. So if you can imagine a quadratic equation, or rather a quadratic relation, it might look something like this. So there we go, we have our quadratic relation, and we have a couple of x-intercepts. So the difference between a quadratic relation and a quadratic equation is this is a quadratic relation. It has lots of different y values. A quadratic equation is only focused on those places where it crosses the x-axis. So we're looking for points this time. Points, places where what would have been a quadratic relation crosses the x-axis. So as I said, that was one possibility there where we have sort of 2 points. Another possibility for us to have one solution is if our parabola comes down and hits the x-intercept and touches it only once, kind of right there. And again, the difference between a quadratic relation and a quadratic equation is you're looking at the relation, you lose the rest of the graph and you just focus on the x-intercept. That is now a quadratic equation. Last but not least, a third and, I'm running out of space a little bit here. A third and final option for this is if we have a parabola and let's say it's over here and it opens up and there are no x-intercepts. So in this case, this is the quadratic relation, and now we look at the quadratic equation, which focuses only on the x-intercepts, and there's none. So these are our two possible answers, i.e. 2 x-intercepts, one possible answer, i.e. 1 x-intercept, or 0, number 0 solutions, i.e. no x-intercepts. So that's what we're focusing on this unit, quadratic equations and solving them. And our number of possibilities are 2 solutions, 1 solution, or 0 solutions. So we're not going to spend any more time on this page. You'll notice that right here, sort of in part A, it says in this unit we're going to look at 3 different ways to solve quadratic equations, and the first, which we're going to spend lesson 1 doing, is by rearranging to isolate x if it appears only once in the equation. So let's actually jump into lesson number 1 now. We'll just slide down, and here is lesson number 1. Now again, it does a summary at the beginning of the note here as to what I just talked about, so let's just jump into the when should I use this method for solving. So this method, called rearranging and taking square roots, which I guess I will highlight up here since it is one of the 3 methods we're going to be looking at, You want to do this when the x variable appears only once in the entire equation. So when our x is, in a sense, already super close to being isolated. The method itself is to isolate the squared term and then square root both sides, and recalling that there will be plus and minus versions of our answer, and then solve for x. So never mind the method. Let's just jump in and I'll sort of talk you through a few of these. So here's our first one. The way I normally model this for my students is to say x squared equals 25. What is my variable? So my variable is x. And what's happening to x currently? Well, it's currently being squared. So how do we undo squaring something? We square root it. And we do the same thing to both sides to keep it equal. So now we have x is equal to plus or minus 5. Now the thing about the plus minus is that you need to include that. And the reason is, I'll sort of just show you over here, is if we have plus 5 being squared, we'll get back our original value of 25. But if we have negative 5 also squared, we also get to 25. So which of these two answers is right? Well, I guess the short version of that is that both of them are right. So we need to include that plus minus. It's super important to have it here when you're taking the square root of a number in this unit in particular. Just to tie this back to what I was talking about earlier, if you could imagine there was a quadratic equation that looked, if I were to graph this, x squared minus 25 equals 0, just sort of move the terms around a bit, it would look something like this. Obviously this is a sketch, but what I want to draw your attention to is that there are 2 points here, and those points would be negative 5 and 0, and this point over here would be 5 and 0. So they correspond to our two solutions right here. Again, we're not interested in the graphing this time. We're not interested in the parabola part. We're interested only in those places where it crosses the x-axis. And we can see visually that there would be two answers for this one, which is why we need both plus and minus 5. If we put just plus 5 there, you've really just said, we don't care about you over here, get out of here. What we need to do is include both, and we do that by doing a plus and minus. Hopefully that makes sense. Let's jump off to a second example. So we have 2x squared equals 98. So again, where's our variable? Well, our variable is x. It's having two things done to it. It's being squared and it's being multiplied by 2. So as a rule of thumb for us, and I want you to write this down on your note, we are going to be isolating by doing BEDMAS backwards. And when I say BEDMAS backwards, what I mean is we want to be undoing operations in the opposite order than if we were trying to evaluate, which means that we are going to undo adding and subtracting before we undo dividing and multiplying, before we undo exponents, and before we work on brackets. So that's the order that we're going to follow. So if we're following BEDMAS backwards to isolate our variable, the first thing that we're going to do is not the exponent. The first thing we're going to do is divide both sides by 2. And when I divide both sides by 2, I have x squared equals 49. Okay, so I've taken care of one of my two operations. I undid multiplication by dividing. Now I'm going to undo the squaring, as we did in the first example, by square rooting both sides. And that's going to give me x equals plus or minus 7. So again, if you want to think about the answer, very similar to what I did with the first one, where I drew like a little sketch. We'd be having this sort of action happening, and we have these two x-intercepts, and those two x-intercepts would be positive 7, 0, and negative 7, 0. So that's how it works. Let's work one more example before we stop this lesson and head into part 2. Okie doke. So here we have x squared plus 64 equals 0. So here's my variable, x. It's having two things done to it. It's being squared, and it's being added to 64. So if I'm following BEDMAS backwards, the first thing I'm going to do is subtract 64 from both sides to keep this thing equal. So subtracting 64 from both sides. My next line then is going to be x squared equals negative 64. And I am going to now square root both sides to isolate my x. Now here's where it falls off the rails for us, because we can't take the square root of a negative number. And the reason is that a square root means you have two identical values that multiply together to give you 64. They have to be the same. So a positive 8 times a positive 8 is going to give you positive 64. A negative 8 times a negative 8 gives you positive 64. There's no two identical values that will multiply together to give you a negative value. So once you've reached this stage, we can say that there are no real solutions. There are no real solutions for this, i.e. there are no values for x that will make the left side equal to the right side. How would this look if we were talking about a graph though? So again, if we were talking about a graph, what this would look like is, so here's our coordinate plane. Our parabola would have a vertex up here at 0, 64. It would go up like this. And you can see visually, well, there are no x-intercepts, which means there are no real solutions. So again, that's going to line up with what we know about parabolas and what we've just learned about solving quadratic equations. So I'm going to stop it here, and we have a few more examples to get through before we get to the homework. So I will see you in part 2.